Hello, everyone. Thank you for joining us for the next session of our Securing AI Apps on Azure series, Deploying an AI App to a Private Network on Azure. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. And while we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It'll be available to view on demand within 24 to 48 hours on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenters. Thank you so much for joining today.
Hi, my name is Matt. I am a program manager on AI Search.
Hey everybody, my name's Anthony and I lead the Python advocacy team at Microsoft.
So I want to jump right in and basically talk a little bit about what we're going to be securing today. So this is all about security, but before we get into the details, I want to talk about what we are securing. So if you navigate to the link right here at akka.ms/ragchat, you can get access to the source code for this demo. I'm running it on my laptop right now. Basically what it is it is a chat with your data demo. It uses something called retrieval augmented generation, or RAG, to chat with your data. This is a pretty full-featured demo, so we really encourage you to check it out. But you can basically ask it questions in natural language, and it will give you answers back about any data you've given it. So this service architecture is a little bit complicated. There's a lot of components, so let's dive right in. We started off with the UX, which is what you just saw. The UX is a single-page application. It is hosted on Azure App Services. This app server, again, Azure App Services, we've got a front-end app and we've got a back-end app. The back-end app is written in Python. When we ask a question, we basically go to Azure AI Search, which is a AI-optimized search engine. We get a bunch of relevant documents back. We then send that over to Azure OpenAI with an additional prompt to basically say, hey, here's a bunch of documents that are relevant to this question. Can you answer it using those documents? It comes back saying hey, this is the answer, or I don't know. When the app starts, we actually include some sample data from a fictitious company called Contoso. So you could just kind of set up your Azure AI Search using a template, and the data is automatically ingested and set up for RAG. So that's all great. We now have this RAG demo, right? And what we basically want to do is we want to make it so that anybody who's on the internet who tries to access our app gets a screen like this, right? Because a lot of times these RAG apps are basically working on sensitive content. We don't want anybody on the internet to be able to even access it. We can have authentication, but authentication sometimes is not enough. We actually want network layer security. So today's topic is going to be all about this screen. How do I make this show up? What do I have to do to configure my app such that it is properly secured so that only the people from the right network can actually access it? So when we talk about network security in Azure, we really focus on this concept called a virtual network. A virtual network is essentially a resource in Azure that you can put other resources in, and it kind of creates a virtual boundary around them. So you can see here that we have the same architecture, but now it's enclosed in this virtual box called a virtual network. And if you check out this link here, you can actually see the source code that actually makes it private. Basically, rather than basically what happens is we don't have to change much application code at all. We actually just provision our resources differently. So when it comes to securing things in the RagChat demo, it is mostly a infrastructure change rather than an application change. So what happens is once we put this in here, we have another virtual network where we actually we think about virtual networks. We think about things called subnets, and subnets basically are networks inside networks. So when I have a resource like Azure AI Search and Azure OpenAI, we associate them with the virtual network using a concept called a subnet. Subnet is basically partitioning this virtual network into smaller slices. App server gets its own subnet. That just has to do with how the integration with subnets works. But Azure AI Search and Azure OpenAI can share their own subnets. It's not shown in this particular diagram, but the way Azure AI Search and Azure OpenAI are attached to the subnet is through a technology called Azure Private Link. Azure Private Link, you might have heard of a concept called private endpoints. If you haven't, private endpoints are basically secure connections from a subnet inside a virtual network to a resource such as Azure AI Search or Azure OpenAI. All the traffic that travels over the private endpoint is guaranteed to travel over the Microsoft backbone. It's never exposed to the internet. In fact, if you are not in this subnet, you actually can't get access to the private endpoint at all. So these are a bunch of various network things that we need to set up. There is a lot of template logic required. So at a very high level, I'm going to kind of cover some of these templates. Basically, when you create a virtual network, we use a technology in Azure called Bicep. Bicep is a templating language that actually provisions Azure resources for you, so you don't need to go into the portal and click through and provision things. So right now, we are using Bicep that's actually present in the repository. In the future, we're going to be using a technology called Azure Modules, where we're going to use predefined Bicep files that actually creates the networks for us. So we don't need to worry about so if I go into the code right now, I actually had to kind of define, hey, there's a resource called the virtual network. I have to know a lot about how it's set up. The advantage of using modules is going to be that, hey, I can just not worry about the inner details of how it's set up. I can just kind of focus on calling it much like you would call a function in your favorite programming language. Now, what's going on here is in the previous slide, we talked about, hey, we have to set up subnets, these partitions of virtual networks. We actually define these subnets in Bicep. What's more is we talk about, when we talk about subnets, the main thing that kind of makes subnets separate is different IP spaces. So we have this 10 dot, in IP address lingo, 10 dot IP addresses are actually private IPs. You're not going to find any device on the internet that has an IP address that's publicly accessible that's in this space. So when you set up a virtual network and you say, hey, I want a 10 dot IP, you're not going to kind of collide with like some random app somewhere, because this is reserved for private networks. There's a couple of properties we need to set to make this work. Namely, when we integrate subnets with certain resources, and let's pick on app services for a second, we actually need to explicitly delegate that subnet to the app service. The reason we need to do this has to do with how the app service works. But basically know that like the great thing about having these templates written for you is that, hey, I can set up these delegations automatically without clicking through the portal. So I'm more confident everything works. If I didn't set up this delegation correctly, the app service actually wouldn't be accessible through the virtual network, and we would kind of not be able to use the privately accessible React Chat app. Moving on to the next slide. So I talked a bit about private endpoints already, but essentially private endpoints consist of multiple parts. I mentioned earlier in the presentation that we don't really change any app code when we set up private endpoints. And why is that? Well, it turns out that private endpoints, because they connect a resource to a subnet, right? There is this private connection. And the way that works internally is that there is a private IP that needs to be used. Well, it's just an IP. It's not actually a separate domain name. What happens is that there is a DNS server that is provisioned alongside the private endpoint. And this DNS server, basically, it knows about the private link. And it basically creates this kind of fake domain called private link dot, and then whatever domain your resource uses. So in the case of Azure OpenAI, we're going to use openai.azure.com. This private DNS zone actually maps the original URL. So in this case, we auto-generate resource names when we provision them to the Bicep. So that's why this looks kind of like a goofy name. But you could have any name here. Basically, if you have this Azure OpenAI resource and you create a private endpoint, the DNS name that you use to call the actual, like, let's say I want to call embeddings. Well, I get my URL, I get either my Entra ID resource tokens, or I get my API key and I call it. When I'm inside the subnet, I still use the same URL. The DNS zone maps this regular name to the private link name, and then that resolves to the private IP. So by using these private DNS zones, we actually don't need to change any app code at all, and it's all basically done through Bicep templates. Where your code run matters. So when I am on my laptop and I am hosting this RAG chat app, I'm on localhost. There's no Azure DNS server. I never touch private link. I can have the same app privately deployed. And because I don't have access to this private DNS server, I can't even get access to the correct IP. Like, it wouldn't resolve anyway because I'm not inside the subnet. So through this kind of DNS setup, we can use Azure Private Link without any code changes. Provisioning private endpoints in Bicep, because there's this DNS zone, it's a little bit more involved, where essentially we need to provision the DNS zone and the private endpoint. Again, we're hoping to simplify this in the future as we adopt some pre-written Bicep modules that hide this complexity. But because all the complexity, again, is in Bicep, you don't have to worry about it when you're developing your app. So I already showed this demo, but basically there's not much to show. Basically, you see an error 403 if you're outside the subnet. It's completely inaccessible. There's no way in. In my demo, again, to reemphasize, we have a login that the login is not even accessible because I can't even get to it. It just says error 403 forbidden. So it's not much of a demo, but it really shows you what an external user who has found your website would experience if they're not inside the virtual network. Before we go to Azure networking options, and Anthony is going to kind of walk us through what that looks like, I think we had a question.
The question, Matt, was, would using a private network like this cause slowness in the streaming with Azure OpenAI in the UI?
And that's a great question. And the answer is there should not be much slowness, especially if the Azure OpenAI service and the app service are in the same network, the same region. The reason why is that private endpoints travel over the Microsoft backbone. So the fastest you can get in Azure is to have two resources in the same region. Because private endpoints don't change any like routing. They basically just, in fact, they actually force the traffic to travel over the backbone and not over the internet. So you shouldn't observe much speed difference. Really, it's just an extra DNS lookup, and that only happens once. DNS resolvers, which actually kind of translate the domain you use to call Azure OpenAI, it caches the IP address so that you do that lookup, and it caches the private IP. So there really shouldn't be any additional slowness from using private endpoints. The fastest configuration, even in the private mode, is always to have all your resources in the same region.
Okay. Cool. All right, I'll take over from here. Thanks, Matt. So I wanted to go through like a high-level overview of Azure networking options, because so far Matt's talked about how in this demo application we've got a web app that uses a whole bunch of Azure services. That includes Azure OpenAI. It includes cognitive services for document intelligence. It has AI search for the vector search capability. So there's a lot of components, both the application, which is custom code, custom Python code, a web app, and then some PaaS components, which are deployed in Azure. In the template that we mentioned, we've got a version of that template where all of that infrastructure is provisioned in a VNet. So Azure has a whole bunch of networking concepts. And if anyone else on the show today is like me and could have grew up with traditional networking, then I wanted to kind of draw some analogies between those traditional networks and the Azure concepts. So in terms of Azure networking services, we've got 4 sort of categories, which is the connections. So that is how you would connect into networks or connect between networks. And the one we've been talking about so far is virtual networking, or VNets. We've also got things like peering, virtual WAN, which is a global version, DNS VPNs, express routes, and IPv6 as well. So Azure networking itself is a huge area of capability within Azure. We've also got on the security side a range of different services for protecting, so controlling traffic and restricting traffic in between networks, depending on the types of traffic and what it is you're trying to secure. We've also got on the delivery side, so this is where you would cache or proxy traffic. So application gateway is a WAF, so it's like a web application firewall. We've got Azure Front Door, which is a combined WAF and CDN. So that is where you can proxy web applications in particular, and also cache assets and deliver them globally. And then we've got load balancing capabilities, which are load balancing an application within a region or globally. And then also on the monitor side, we've got services for monitoring networks across multiple data centers or even across planes as well. So you can monitor networks in Azure and beyond that as well. The concept that Matt talked about, he talked about two things. One is the virtual network, which is, I guess, the closest thing I can think of. The analogy would be a VLAN in a traditional network. In a traditional network, you can create a VLAN by tagging packets with a VLAN ID. That basically separates the network, and then inside that VLAN, you can slice it further using subnets. So it's similar to that in Azure, except that a VNet in Azure has a lot more capabilities than just the IP tagging. You can choose how and where you connect them. You can manage them all in one place. And you can also set control between subnets and within VLANs as well. So in this, we've basically got a VNet that's been configured and then multiple subnets for different components in the backend. And then optionally, you can also introduce a network security group, which is a way of controlling traffic between the subnets. So you can say which protocols are supported, which ports are supported, and which traffic you want to flow between the subnets in the VNet. So once you've got your application set up using VNets, you've basically isolated all of the endpoints and all of the traffic into a separate private virtual network. And then you need to work out how, since that's all now private, it can't be accessed via the internet, it can't be accessed from anywhere outside of that network. You need to decide what methods you want to use to actually get into that network. So depending on your use case, we've got different options. Another thing to mention is that you can also connect VNets together using virtual network peering. So this can be across geos where you've got multiple virtual networks and you want to connect them together for specific purposes. So if you've got multiple applications sitting in different VNets, you can plug them together using virtual network peering. And this can also work across regional boundaries as well. I mentioned network security groups. This is a sort of firewall type capability for controlling which traffic is allowed to flow between the subnets in a VNet. You can also use NSGs to control traffic that's going from the VNet outbound to public internet or to an external network as well. NSGs are kind of built-in capability that you can apply into the virtual network. Another thing that's important to mention is virtual networks. You get 50 virtual networks for free in an Azure subscription. So virtual networks are actually available for free for up to 50. And then there is a small charge beyond that as well. Another service we have available is Azure Bastion. Azure Bastion, normally you would see in an environment where you've got virtual machines. I kind of think of it as being a sort of control and proxy solution for remote desktop and SSH. So if you've got virtual machines sitting in Azure, either Windows ones or Linux ones, and you want to get access to them using remote desktop or SSH, and you don't have a VPN solution, you can use Azure Bastion to basically form a SSH or RDP gateway that you can connect through, and then you've got a secure connection to then jump into the VMs on the back end. In this solution we've talked about so far, there are no virtual machines. I just want to highlight this as an option because absolutely you should never put a VM, you should never expose RDP to the internet or SSH. I've been working in data centers for long enough to know that's a terrible idea. And so you should definitely proxy and control which IPs inbound can go through and lock down those as securely as possible. Ideally, you'd have a VPN in place, but Azure Bastion is available as a way of basically controlling RDP or SSH traffic inbound to virtual machines deployed in Azure. We then have another option, which is a web application firewall with Azure Front Door. There's actually multiple services in Azure that have a WAF type capability. If you're not familiar with a WAF, when we think of networking, we traditionally talk about the OSI layers 1 to 7. So when we talk about firewalling or controlling IP traffic, it depends on which protocol you're talking about. So with web apps, if you're controlling HTTP traffic specifically, for example, if you wanted to say, we want to catch cross-site scripting attacks or XSS attacks, or we wanted to try and catch SQL injection attacks at the front end, that type of knowledge for the firewall, it has to read and understand HTTP. HTTP is a layer 7 protocol, so we're talking about basically a layer 7 firewall. A web application firewall is a firewall specifically designed to have rule sets for web apps, and it sits at the top protocol. So a web application firewall is different to a traditional network firewall in that with a traditional network firewall, you're just controlling ports. So whether that's TCP or UDP, you're controlling the inbound and outbound traffic via the ports. Whereas with a WAF, you can do much more granular rules that say, okay, I actually don't want anyone to be able to log into this particular page, or we want to catch these types of web application vulnerabilities. So WAF is not a concept that Microsoft invented. It's been around in the industry for some time, but we have a WAF capability in a few different services in Azure. So Front Door is one that I would recommend as being a way of exposing a web app from a VNet to either the public internet or to your local network. And it would basically introduce the layer 7 firewalling, so you can configure custom rules for the web application, or you can bring in our default rule sets. And Azure Front Door comes with a lot of best practices and a lot of rules and scans for things like SQL injection, cross-site scripting, and actually a lot of the OWASP top 10 sort of web app vulnerabilities. So we've got built-in rules for a lot of that in Azure Front Door with the WAF capability. It's also got built-in DDoS protection. So if for whatever reason your application is under attack externally as a distributed denial of service, because we're exposing this service for you, then we can capture that DDoS traffic and protect you against that out of the box. It also has CDN capabilities. So if your application, you want to have caching of static assets, like images and CSS files and stuff like that, and you want to have those cached in different geographies around the world, you can turn on the CDN capability in Azure Front Door, and that's all built in. So we also have another service called Azure CDN. What we recommend now is that you actually just use Azure Front Door with CDN instead of using Azure CDN directly. Okay, so that's a lot of a lot of product names. So we've got a couple of these decision trees that I find really useful for working out which is the best service for you to use, or which service should you start with, and then look at the requirements. So In this case, we're looking at protecting and exposing a web application. So that is HTTP. You then need to decide, is this internet facing, or are we just proxying it through to another private network, whether that's an on-site network or another Azure network? If it's not internet facing, you can use Application Gateway, which is another service for controlling HTTP traffic in particular. It's not as full featured as Azure Front Door. It doesn't have the CDN capabilities, for example. But if you're not exposing it to the internet, you don't really need CDN or DDoS protection. If it is internet facing, then you want to decide whether you want this app to be deployed in multiple regions, or are you just deploying it in one data center. If it is in multiple regions, then we've got different options depending on how much caching you want and which components you've got in the back end. But all of those really lead you to a combination of Azure Front Door, Azure Load Balancing, which is a global load balancing solution, or Application Gateway. And we do have a link to the slides if you want a copy of this diagram as well.
Anthony, we actually have a question from the audience. Does Web Application Firewall automatically block SQL injection distributed denial of service?
Okay, so the WAF in Azure Front Door, when you provision that, there's a default rule set that includes SQL injection as well. And it includes cross-site scripting and SQL injection. So it will detect that for you.
Thank you.
Yeah. So Azure Front Door is a sort of service that combines a few different capabilities. It combines doing failover between different geos. So if you've got the app deployed into 2 or more different regions, it would do the failover between regions automatically. It does the security on the edge, so it does things like DDoS protection that we talked about, and also a WAF. And because you've got that caching and it has a really high performance SSL offloading option as well, then you can improve the performance of the application. Okay, so we've also got the private network capability. So far I've talked about exposing an application, a web application, to another network or to the internet. But you also have to think about how you get access into the VNet to talk to the backend services. So, you've got AI search in there, you've got document intelligence, but how do you upload the documents? How do you run custom queries on the backend? So this is where, if we went to like traditional networks and we talked about VLANs or VNets and subnets, this is where you would either have a site-to-site VPN or a point-to-site VPN, or you'd be physically connected to the network. Now, you can't be physically connected to the network because it's in the Azure data center. So we have effectively 3 main options for connecting into private networks in Azure. One is ExpressRoute, which is a sort of point-to-point networking solution to connect typically a sort of on-prem network into an Azure network. So I'd say that's akin to MPLS, if you're familiar with that technology. We have Azure VPN, which is a VPN as a service, and that has both point-to-point and point-to-site. Has both site-to-site and point-to-site VPN options. And that provisions a VPN tunnel to whichever network you want. That can include the internet. And then we've also got SD-WAN tunneling, which you can do as well. So ExpressRoute is a way of using one of the global network peers that we have to connect your own network over a private connection into the Microsoft data centers, and then plug that into different VNets. So this is sort of a larger end solution. Up to 100 gigabits is supported, which is a lot. So if you need like a large amount of transit and throughput between your own network, whether that's spanning one or multiple regions, and you need to connect into Azure, we'd recommend ExpressRoute as the sort of as the option for doing that. And we've got a lot of network partners that can help you connect into other data centers or your actual on-prem offices and networks. VPN gateway is another option. So I guess in a traditional network, you'd have like a VPN device that would sit at the edge of the network and expose a VPN connection endpoint. And then you'd either have a site-to-site VPN, so you join two networks together over a VPN tunnel, or a point-to-site, which is where you have a single device like a laptop or a PC connecting into the network using a software client. So Azure VPN Gateway is available as a service that you can provision in Azure, and I've got it provisioned in this demo app, and I'm using it to connect from my Mac into the VNet, so I can access all of the services in the back end of the network. But I'm doing that using certificates to connect my local machine into that network. So that is also another option. So we've got this set up in a demo, and you can have a look through the architecture. Is there any more questions before I go?
We don't have any more questions right now.
Okay, cool. So there's a few other things I want to kind of draw your attention to. One is that we have, I guess I've covered a lot of different services, and each of those services has lots of different configurations and modes and options. And even when you've got those configured, it can be quite overwhelming to understand, is this the best setup, or how does the security posture of what we have deployed kind of compare with Microsoft's recommendations? So we have Defender for Cloud as a service, which is available in Azure. That will actually assess your Azure infrastructure, look at the services that you've got configured and deployed, how they're deployed, how they're architected, and then give you recommendations on the best ways to protect those. And that's not just in Azure. You can connect it to AWS and to Google Cloud as well. And it can look at the architecture of all of those and give you recommendations as to things you can do to improve the security of them. We've also got built-in benchmarks. There's the MCSB benchmark, which is the Microsoft Cloud Security Benchmark. We also have some mapping to different compliance standards. So there's some of the European data security standards, and there's also some of the US ones. So we've got mappings with the rules in there. So if you've got regulatory requirements, which these days, if you don't, you're very lucky. I think everybody does. Then we basically give you a checklist of stuff to work through on the regulatory side, and also look at data security and understand where your data is and how you can better lock that down. So we use this tool to look at our demo apps, as well as obviously our internal infrastructure. So when we're sharing templates and examples, we've done that assessment. So for example, if you deployed this RAG demo without VNets, it would have come back with this list of recommendations that covers a lot of the stuff that we've talked about today. So the RAG demo stores the documents that it's indexed in a storage account. By default, that storage account would be public. So it's recommending that we take that off the public internet. It's also pointed out that a lot of the cognitive services components, so the Azure OpenAI is on the public internet, and it shouldn't be. So it's recommending that we restrict network access from Defender. So this is how you go from, okay, we've got an application that we've deployed, we've got something running, how do we make it more secure? Defender is a great place to start because it will scan the app and the infrastructure and then give you recommendations as well as links on how to set that up.
Really quickly, we have a question coming in. Does web application firewall block or allow people with their external IP?
You can control which IPs are allowed inbound, but the WAF in Azure Front Door is designed for controlling access from the internet into an application on Azure.
Thank
I think
you.
that answers the question.
Yeah, great answer.
So that's how we established the design of this demo, was to work through the Defender recommendations. And then once we'd done that, we've been working on some GitHub actions, which we'll look at. So Defender works by looking at the deployed infrastructure and then giving you reports on best practices. Now, there's a flaw there, because once you've deployed the infrastructure, it's telling you what the security issues are with the deployed infrastructure. But ideally, you'd want to see those risks before you deploy it to Azure. And that we can do with a scanning tool that looks specifically at Bicep files. And it will look at the Bicep and assess what infrastructure would be deployed from that template. And then it compares it against a rule set of hundreds of different rules, which includes both like general best practices as well as security best practices. So what we've got in GitHub Actions and also in Azure Pipelines is the ability to run a check that can be run as a sort of CI/CD check that will look at the Bicep and tell you, okay, for example, you've got a VNet that doesn't have an NSG. You've got some parameters in your Bicep that were missing the @secure decorator. So in the deployment log, they'd be stored in plain text. So PS rule is a way of detecting potential security issues in the Bicep before they're even deployed to Azure. So we'd strongly recommend using a rule scanning tool like this. Or there's Defender for DevOps, which does a similar thing. And we've got links for that as well. Cool. Okay. Pamela, I think on the next steps. Is Pamela still on?
Why don't I take the next steps?
Okay.
Just so I can, here we go. Oh, you got him. Great.
Do you want to cover that, Matt?
Yeah, absolutely. So we want you to actually try all of our samples. So security is definitely a really important part of it, but it's just one part of it. Check out our RAG chat sample, the one I showed earlier in the presentation, aka.ms/ragchat, because there's so much more to this. It shows you how to integrate Azure OpenAI with AI search. In addition, like, how does the authentication work? We have docs. We have other Reactor sessions on this very topic. Feel free to take a look. We've got two other really important links for you to review, the Azure Well-Architected Framework and the Azure Verified Modules, because these links are going to help you build better apps that use Azure more effectively, faster. And last but not least, we want you to take a look at the aka.ms/azai link to find even more great samples. Basically anything in languages such as Java, JavaScript, Python, .NET, covering topics all related to AI. So please take a look. I think that's it for our Securing AI Apps on Azure session, but it's been really fun. There have been some great sessions, and if you missed any, check out the recordings. The link is below. I think that's all we have time for today. We wanted to see if there were any more questions from the audience, but I think we've answered everything. Any more remarks, Anthony, before we sign off?
No, we make these slides available. There was a link at the beginning of the talk. So the decision tree slides in particular, if you wanted to go through those again, we can do that. And there's also links to the services and everything we've talked about today in the show.
All right, super awesome.
Thanks, everyone. Thanks to our speakers. We've got the link for previous sessions of the series on the screen. We also are always looking to improve our sessions and your experience. If you have any feedback for us, we'd love to hear what you have to say. You can find the link on the screen or in the chat. Today's event code is 32027. We'll see you at the next one.